What we're going to talk about today is infinite geometrical series. Let's say we have these dolls. My wife and daughter love these things. So do I, but don't tell anybody. These things are really cool. Let's say we have infinite amount of dolls and they're all in this shape where the first one, let's say we want to put water in each of these. The first one has 1 ounce of water. The second one would carry a half an ounce. The third one would carry a fourth of an ounce. The fifth one would carry an eighth. The next one carries 1/16th and 1/32, and then 1/64. Okay, and then we want to figure out how much water we need to fill all these up. And then let's say these are just a few of them. We keep going forever into the future in the same ratio, cutting them down in size in terms of how much volume of water we need to fill up each one. Now, to do this, we would have to add the first one, which is 1 ounce, then we need a half an ounce, then a fourth of an ounce, then an eighth of an ounce, then 1/16th of an ounce, then 1/32 of an ounce, then 1/64 of an ounce, right? You get the picture. 1/128th, 1/256 plus 1/512 plus 1/1024. That's a good chance to learn the perfect squares of 2. And then we would add these. 1, and then we add 1/2, so that's 1 and 1/2. Then we add 1/4, that is 1 and 1/4. Then we add 1/8, that would be 1, and if we do the math, that would be 1 and 7/8. Then we add 1/16, right? And then that would be 1 and 15/16. Then we add 1/32. That would then be 1/31/32. Then we add let me just make sure you're with me on the same page. When we add 1 and 15/16 plus 1/32, we do it this way. So we have 31/16 plus 1/32. The common denominator is 32. So then we'd have 62/32 plus 1/32, and that is 63/32, which then simplifies to 1 and 31/32. Then we want to add 1/64. To do that, we would, if we did the math, and it's a good practice to do it, then it'd be 1 and 63/64. Then we want to add 1/128. That would then be 1 and 1/27 over 128. We want to add 256. Then if we did that math, it would be 1 and 255 over 256. And then we add 1/512. Now, as you could see that if we keep doing this forever into the future, we're going to get something like 1 and 999,999 over a million. And then we could keep going further. Okay, well, 1.9999999, infinitely. That would be a lot of work. There is an equation, and this is the equation. It's the sum of an infinite series is A1 divided by 1 minus r being the ratio, a1 being the first number in the series. Now let's see how this works in our example of the Russian dolls. We have, if you look at a1 over 1 minus r, a1 is that first number in the series, okay? And that first number in the series is 1. And then 1 minus r. To get the r, to get that ratio, if you can't see that it's all dividing in half, that's fine. You just take the second number and you divide it by the first number. So 1/2 divided by 1, and that is 1/2. So the ratio that's cutting down the series is 1/2. So the equation will be 1 over 1 minus 1/2, which is 1 over half. And that is multiply the reciprocal. So 1 times 2 over 1, and that's 2. So the sum of that infinite series is 2, which is the same thing that we got over here, the 1.99999999999. It's just a faster way of doing it. Let's do another one. What is the sum of this series? Half plus fourth plus eighth plus 1/16th, and so on and so forth. Hit the pause button right now. Give this a shot on your own. It would be good practice, and then we'll do it together. All right, let's do it together. I hope you tried it on your own. So when we have a half plus a fourth plus an eighth plus 1/16th, so the sum of this infinite series will be a1 over 1 minus r. a1 is the first number in this series, which is 1/2. And then we have 1 minus r. r, once again, the ratio is, you just could take the second number divided by the first number. So the second number here is 1/4, and the first number is 1/2, right? So 1/4 divided by 1/2. So when you divide, you could multiply by the reciprocal. So 1/4 times 2 over 1, and that's 2/4, and that simplifies to 1/2. So the ratio is 1/2. So then we have 1/2 divided by 1 minus 1/2. And then that bottom part, you could just, 1 minus 1/2 is 1/2. So we have 1/2 over 1/2, which is 1. So the sum of that infinite geometrical series is 1. Had we added it out, it would have been 0.99999999999. It doesn't reach 1, but it reaches, infinitely close to 1. Let's try this one. 4 plus 2 plus 1 plus 1/2 plus 1/4 plus 1/8. What is the sum of this geometrical series? I'll give you a second to try this on your own, and then we'll do it together. Let's do it together. 4 plus 2 plus 1 plus 1/2 plus 1/4. If we did this a long way, the first one is 4, obviously. Then 4 plus 2 is 6. 6 plus 1 is 7. 7 plus 1/2 is 7.5. And 7.5 plus 1/4, that's 7 3/4. And then if we keep going, then to say we have 1/8 and 1/16. If we keep going, 7 3/4 plus 1/8 is 7 7/8. Plus 1/16 is 7 7/15/16. It looks like we're getting infinitely closer to 8. But the fast way to do it, we do that equation. The sum of that series, a1 divided by 1 minus r. The first number in the series is 4. And then 1 minus r, the r is that second number, which is 2, divided by the first number, which is 4. So 2 divided by 4, and that's 1/2. So the ratio is 1/2. So we have 4 over 1 minus 1/2, which is 4 over 1/2. So then we could go 4, multiply the inverse of 1/2, which is 2 over 1. So 4 times 2 over 1 equals 8. So the sum of that series is 8, which is what we had over there. Once again, it's not exactly 8. It's infinitely close to 8, but you get the point. So let's try this one. The sum of this infinite series, 1 plus 2/3 plus 4/9 plus 8/27. Try that one on your own. Hit the pause button, and then we'll do it together. All right, so now I hope you tried it on your own. You're going to try these. 1 plus 2/3 plus 4/9 plus 8/27. So the first number in the series, if you look at that equation, we get the sum of this series is a1 over 1 minus r. The first number is 1, right? And then we have 1 minus r. And if to get the r, we could divide that second number in this series divided by the first number. And that second number is 2/3. The first number is 1. 2/3 divided by 1 is 2/3. Any number divided by 1 is that same number. So 2/3 is r. So the equation is 1 over 1 minus 2/3. So 1 minus 2/3 is, let's see, 1 minus 2/3 has to be 1/3, right? So it would be 1 over 1/3, and then 1 divided by 1/3, we multiply the reciprocal. So 1 times 3 over 1, which is 3. So the sum of that series is 3. Okay, this one's a tougher one. Hit the pause button again. You got to try these on your own. Give this one a shot, and then we're going to try it together. All right, so the sum of that series is a1 divided by 1 over r. The first number, the a1, is 20. I used to love a1 steak sauce, by the way, but I don't eat steak anymore. Anyway, so 20 over 1 minus r. So here we go. We have the r is basically, like I said, the r is the second number divided by the first number. That will get you the ratio right away. So that second number is 5. The first number is 20. So if I divide by 20 is 1/4. That's the r. So we have 20 over 1 minus 1/4. 1 minus 1/4, if you want to do it over here, the common denominator is 4, so it would be 4/4 minus 1/4 is 3/4. So the bottom, the denominator is 3/4. So we have 20 over 3/4. That is what the equation simplifies to. Then we could multiply the inverse. So we have 20 over the inverse of 3/4, which is 4/3. And that then equals 80 over 3. That's the answer there. So the sum of that series is 80 over 3. This one, we're stepping it up in terms of difficulty. Give this one a shot on your own. All right, let's do it together. We have 50 plus 25 plus 12.5 plus 6.25. So the sum of this series would be, again, a1 divided by 1 minus r. R is the second number divided by the first number. That second number is 25. The first number is 50. So the ratio there is 25 over 50, which is 1/2. So we go back here that A1 is 50 divided by 1 minus 1/2. That's 50 over 1/2. 50 divided by 1/2, to multiply the inverse, that's 50 times 2 over 1, and that would equal 100. So that's the sum of that infinite series, is 100. Keep going. The more you do, the more you can nail this down. This one you're going to do on your own and leave the answer in the comments below. So let's have these circles that are going to be divided equally every time you progress in the series. So the first one is the area of that circle is 100, and then the area of the next circle is 100 divided by 3, or 33 and a third, and then the next circle is 100 divided by 9, or 11 and a ninth, and then the next circle is 100 divided by 27, so 127ths. And then we have infinite amount of circles, and they all kind of go down the same line in terms of how much they're dividing. Like the next one after the 100 over 27 would be 100 over 81. And what I want to know is if you add up the sum of all the areas of all these circles and they go on infinitely, what would that sum be? You could, if you want to look at it the equation type of way, what we're asking is what is 100 plus 100 over 3 plus 100 over 9 plus 100 over 27 plus 100 over 81 plus, so on and so forth. Do this one the same way we've been doing them. You got it. You can do it. Trust me. I encourage you to subscribe because I'm going to have more videos that are going to help you in algebra and geometry equations,